All right. Welcome in, everybody. Welcome back to the stream. Hope you're having a wonderful day so far. Let's get the Twitch going as well. There we go. And we are live. Let's go ahead and get the chat loaded up. Get the chat loaded on up here. All right, and we're loaded up. Sweet. All right. Hope you guys are having a wonderful evening. Today is Saturday, March 22nd, 2025. And we're back teaching ourselves some more Python and computer science. So I appreciate you all for being here, joining me once again. We're going to be reading some DSA, I believe, is the plan for today. Right? I believe DSA is up for today. All right. Efficiency of hash tables. Oh, there you go, linear probing. Well, sorted maps here. All right. Let's dive on in here. Give me 1 second. All right. Well, I need my headphones actually too. Give me 1 second. Gosh dang it. I need my headphones. Wherever those at. Jacket. Okay, cool. How you guys doing today? Welcome back into the channel. I hope you guys are having a wonderful day. It's awesome to hear from you guys. Hey, Edwards. Thanks for coming in, Mr. Edwards 404. It's awesome to hear from you again. We got some pretzels, snacks here. So, it's gonna be a good day. How we doing, everybody? What are we studying tonight? What are we working on? Let me know what you're working on. You guys doing homework? What are you reading? What are you watching? What are your projects? Let me know. If you guys are here, a part of the early crew, leave a thumbs up. Leave a thumbs up on the stream for the early crew. Appreciate you guys joining me. All right, let's get this show on the road. How about, yeah? 10.3 sorted maps. Right? Here we go. The traditional map ADT allows a user to look up the associated value with a given key, but the search for that key is a form known as an exact search, right? So exact search. For example, computer systems often maintain information about events that have occurred, such as financial transactions. Organizing such events based upon what are known as timestamps, if we can assume the timestamps are unique for a particular system, then we might organize a map with a timestamp serving as the key and a record about the event that occurred at that time as the value. A particular timestamp could serve as a reference ID for an event, in which case we can quickly retrieve information about the event from the map. However, the map ADT does not provide any way to get a list of all the items ordered by the time at which they occurred. or to serve for which event occurred closest to our particular time. On on the intentionality, uh, oh, on on the in fact, the performance of hash-based implementations of the map ADT relies on the intentionally scattering of keys that may seem very near to each other in the original domain so that they are more uniformly distributed in the hash table. In this section, we introduce an extension known as sorted map as the sorted map ADT that includes all behaviors of the standard map plus the following. So map.findMin returns the key value. So then we'll say sorted map ADT. Okay, let's go here. Let's say give me a simple def of exact search in terms of hash tables. Hey Tim, how's it going, dude? Welcome back in. Awesome to hear from you. Okay. Exact search in hash tables refers to looking up a specific key to retrieve its corresponding value. Right, so looking up a specific key to retrieve its corresponding value. The key is hashed using a hash function. Right? Which maps it to an index in the table, allowing for big O of 1 average time complexity for retrieval. Perfect. Okay. That makes sense. So the sorted map ADT, right, methods, number one, are map.findMin, right, return the key value pair with minimum key, right, or none if the map is empty. What you guys working on? Let's chat it up. What you guys working on in the chat? Let me know, guys. Let's get some music going. Let's get some tunes going. While we study here, let's get some music, huh? Here we go. One second. Let's get some tunes here. All right, let's play. I think we left off last time on the Sweet Nita. Here we go. Let's give this a roll out. All right, let's get some tunes going here. Some smooth music. Let's keep on reading. So we're reading, this is DSA in Python. This book can be found in my Discord link down below. Number 2. The map.findMax, right? Which will do the same thing of the other one, but return the key value pair that is the minimum with the maximum key. Or none. Okay. We have number 3, which is going to be map.findIt. Oh, find LT. So we want to find LT. It says, let me turn that down slightly for you guys. So that is return the key value pair with the greatest key that is strictly less than k, right? Or none if no such item exists. Okay? So map find LT. Return the key value pair with the greatest key that is strictly less than k. Okay. Then we have map dot find LE, which is going to be something similar but the least probably. With the return the key value pair with the greatest key that is less than or equal. Less than or equal to k. Right, and then we have find GT. So it might seem kind of stupid that I'm writing these out. I'm never going to probably use these functions, and making notes on them, but by writing them out and physically typing them out in their definitions, I'm getting just more familiarity with what they're actually doing. So LE has of k and LT of k. So this is return the key value pair with the least key that is strictly greater than k, or none if no such item exists. Number 6 is map dot find GE. Okay. Return the key value pair with the least key that is greater than or equal to k, or none if no such key exists, right? If no such item, sorry. We have number 7, which is map dot find range start and stop. This is iterate all the key value pairs with start less than or equal to this key, which is less than stop if start is none. Iterate all key value pairs with start less than or equal to key, which is going to be less than stop. If start is none, iteration begins with minimum key. If stop is none, iteration concludes with maximum key. Okay, almost there. 8. Iter on the map. Iterate all keys of the map according to their natural order from smallest to largest. Number 9 is going to be reverse on the map. Iterate all keys of the map in reverse order. In Python, this is implemented with the dunder reversed method. Cool. All right, sort search tables. Several data structures can efficiently support the sorted map ADT, and we'll examine some advanced techniques in section 10.4 of chapter 11. In this section, we begin by exploring a simple implementation of a sorted map. We store map items in an array-based sequence A, so that they are in increasing order of their keys, assuming the keys have a naturally defined order. We refer to this implementation of a map as a sorted search table. So we have an array A of 15 buckets within this hash map, and we have key values and key value pairs within each bucket, and they are sorted in their increasing order of keys. So a figure 10.8 realization of a map by means of a sorted search table. We only know the keys for this map so as to highlight their ordering. As was the case with the unsorted table map of section 10.1.5, the sorted search table has a space requirement that is O of n, assuming we grow and shrink the array to keep its size proportional to the number of items in the map. The primary advantage of this representation and our reason for insisting that the array A be array-based is that it allows us to use the binary search algorithm for a variety of efficient operations. So binary search and inexact searches. Right? We originally presented the binary search algorithm in section 4.1.3 as a means of detecting whether a given target is stored within a sorted sequence. In our original presentation, code fragment 4.3 on page of 156, a binary search function returned true of false to designate whether the desired target was found. I think you should say true or false. While such an approach could be used to implement the dunder contains method of the map ADT, we can adapt the binary search algorithm to provide far more useful information while performing forms of inexact search in support of the sorted map ADT. The important realization is that while performing a binary search, we can determine the index at or near where a target might be found. During a successful search, the standard implementation determines the precise index at which the target is found. During an unsuccessful search, although the target is not found, and the algorithm will effectively determine a pair of indices designating the elements of the collection that are just less than or just greater than the missing target. As a motivating example, so this is just like that Leet code that we tried. Hey Michael, I had texted you on Discord, but I don't think you've seen it. Oh, my bad. I'll take a peek at that. Flopater? Saman? Let me know if I'm saying that right. Flopater? Thank you so much for jumping in. What are you working on this evening? Yeah, I'll check out that message. I'll be sure to check that out. Sometimes it doesn't really let me know when like people that aren't my like direct friends on Discord send me messages. So if I like, I'll have to just go look at it. Yeah. And add ya. Okay. So this is just like that Leet code problem that we just did the other day, where you can do a binary search, but you can use pointers rather than slicing on the array to effectively find the index at where that value would be if it was there. As a motivating example, our original simulation of figure 4.5 on page 156 shows a successful binary search for a target of 22. Using the same data we portrayed in figure 10.8, we had instead been searching for 21, our first 4 steps of the algorithm would be the same. The subsequent difference is that we would make an additional call with the inverted parameters high equals 9 and low is 10, effectively concluding that the missing target lies in the gap between values 19 and 22 in that example. Right, so here, if we're searching for 21, it's not found, it's between the low of 9 and the high of 10 using index tracking rather than slicing for binary search. Interesting. As an example, or implementation, Flopateer, but I go by Tero. Flopateer, gotcha. Thanks so much for clarifying that. But I go by Tero. Sweet, dude. I'll be sure to check it out, Tero. Caravan? I think this is Caravan from like Whiplash. Yeah, this is Caravan. We'll pause it and we'll so YouTube doesn't pick us up. We have to be careful. If we go longer than an hour with their thing on stream, then they get butthurt. So we'll go like this. We'll play some of the stream beats by Harris Heller, which is free of copyright, for a little bit, and then we'll switch back. Okay. In code fragment 10.8 through 10.10, we present a complete implementation of a class sorted table map that supports the sorted map abstract data type. The most notable feature of our design is the conclusion of a find index utility function. This method using the binary search algorithm, but by convention returns the index of the leftmost item in the search interval having key greater than or equal to k. Therefore, if the key is present, it will return the index of the item having the key. Recall that the keys are unique in a map. When a key is missing, the function returns the index of the item in the search interval that is beyond where the key would have been located. As a technicality, the method returns index high plus 1 to indicate that no items of the interval had a key greater than k. We rely on this utility method when implementing the traditional map operations and the new sorted map operations. The body of each of the dunder get item and dunder set item and dunder del item methods will call to the find index to determine a candidate index at which a matching key might be found. For dunder get item, we simply check whether that is a valid index containing the target to determine the result. For dunder set item, recall that the goal is to replace the value of an existing item with 1 if one of the key k is found, but otherwise to insert a new item into the map. The index returned by find index will be the index of the match if one exists, or otherwise the exact index at which the new item should be inserted. For the del item, we again rely on the convenience of find index to determine the location of the item to be popped, if any. Our find index utility is equally valuable when implementing the various inexact search methods given in code fragment 10.10. For each of the methods find LT, find LE, and find GT, and find GE, we begin to call to the find index utility, which locates the first index at which there is an element with a key greater than or equal to k, if any. This is precisely what we want to find for GE if valid, and just beyond the index we want to find LT. For GT and LE, we need some extra case analysis to distinguish whether the indicating index has a key equal to k. For example, if the indicated item has a matching key, our find GT implementation increases the index before continuing the process. We omit the implementation of find LE for brevity. In all cases, we must properly handle boundary cases reporting none when unable to find a key with the desired property. Our strategy for implementing find range is to use the find index utility to locate the first item with a key that is greater than or equal to the start, assuming start is not none. With that knowledge, we will use a while loop to sequentially report items until reaching one that has a key greater than or equal to the stopping value, or until reaching the end of the table. It is worth noting that the while loop may trivially iterate 0 items if the first key is greater than or equal to start. Also happens to be greater than or equal to stop. This represents an empty range in the map. Okay, so now we have this. So we have the sorted table map, which takes from the map base. Non-public behaviors. Find index, right? With a key that we want to find, a low, and a high. So return the index of the leftmost item with the key greater than or equal to k. So return high plus 1 if no such item qualifies. That is, j will be returned such that all items slice table of low up to j have the key less than k. All items of slice table j to high plus 1 have the key greater than or equal to k. So if high is less than low, return high plus 1. Else, so if the high ever becomes less than the low, we return high plus 1. Else, mid is equal to the low plus high divided by 2. If k is equal to the table at that midpoint key, return that midpoint. If k is less than, we will call a recursive on this find index recursion, giving the same key with a low and the high as mid minus 1. So we're using this recursively rather than using it with slices. Gotcha. Okay, then you have del item, set item, iter, reversed, find min. If the length is greater than 0, return a tuple of a key value of the first value in the table, else none. Max will return the last value, -1. Find GE returns key value paired with the least key greater than or equal to k. So we call find index on it. Then you return the k, else return none. Okay. Almost there, guys. We'll read for a couple more minutes, and then we'll move on. Analysis. We conclude by analyzing the performance of our sorted table map implementation, a summary of the running times for all the methods of the sorted map ADT, including the traditional map operations, is given in table 10.3. It should be clear that the length, find min, find max methods run in O of 1 time, and that the iterating the keys of the table is either directional can be performed in O of n time, linear. The analysis for the various forms of search all depend on the fact that a binary search on a table with n entries runs in O log n time. This claim was originally shown in Prop 4.2 and Section 4.2, and that analysis clearly applies to our find index method as well. We therefore claim an O log n worst case running time for methods get item, find LT, find GT, find LE, and find GE. Each of these makes a single call to the find index followed by a constant number of additional steps to determine the appropriate answer based on the index. The analysis of the find range is a bit more interesting. It begins with a binary search to find the first item within the range, if any. Given that, it executes a loop that takes O of 1 time per iteration to report subsequent values until reaching the end of the range. If there are S items reported in the range, the total running time is O of S plus log n. you do that original binary search, and then you iterate yielding each of those items within that range. In contrast to the efficient search operations, update operations for a sorted table may take considerable time. Although binary search can help identify the index at which an update occurs, both insertions and deletions require, in the worst case, that linearly many existing items be shifted in order to maintain the sorted order of the table. Specifically, the potential call to table.insert from within the set item and the table pop within the del item lead to O of n worst case running times, right? Based on the operations of the list class in section 5.4 we call, where when you insert an item, you have to shift all the right values over. When you delete an item, you have to shift all the right values to the left. In conclusion, sorted tables are primarily used in situations where we expect many searches but relatively few updates. Okay, so we'll say, I like this. This is a good little note here. Sorted tables are primarily used in situations where we expect many searches but relatively few updates. And then I will go ahead and capture this within an image, like such. And we'll paste that right on in here. Table 10.3, performance of a sorted map, right? We know that the length is O of 1. When you is the key in, has to run log n to determine if the key is in the map, because we use an array-based map sequence here. Map k equals v, O of n in the worst case, O log n if key is existing to override. You have to check every key to see if it exists. If it doesn't, it's O of n. If it does, you find it in your binary search. Delete has O of n in the worst case because when you delete, you have to shift. Find min and find max run in constants because they just they pull references to the first or last item in the sort. All of these require searching for an index, so log n. Find range requires a log n search of an index over that range and then a report yielding s values. And then iter is log O of n, iter, literal. Linear. All right, cool. Let's go ahead and shift our focus from there. How about, yeah? That was 30 minutes of reading into DSA and Python. If you guys want access to my notes or the book, it's in my Discord link down below, so please join on there, ask questions, and post your own resources in the community resources tab. Also provide your own input and updates into projects or CS50. I've kind of created that to also allow for you guys to provide your own information too. Not only my own. So if you guys have stuff you think people would like, then feel free. Hey Wing Hong, hey Marty, welcome in, dudes. How's it going? What are you guys working on? Let's go ahead and shift over to some Leet code problem, yeah? I'm going to go ahead and push these notes for you guys. Boom. Let's say continued chapter 10. So you guys can find these notes linked down below on my GitHub. If you guys would like access, I highly advise you guys just give them a read over, take a section, a chapter a day, read over my notes for that chapter, read it through twice throughout the day to help solidify the information. One pass over isn't enough, but twice should be good, and it'll help you give the gist about what was really in that chapter without actually having to read it, kind of like a Spark Notes. So all these resources are free for you guys, so I'm trying my best to really document my progress for you guys. All right. Okay, so we're doing a Leet code problem. I'm going to be honest with you guys, I don't really know how to do the next ones. Add binary. Given two strings, return their sum as a binary string. So this would be 12. So that on is 1, that on is 2, that both, so this on, see, I'm just not really good at binary. I'm not very good at it at all. So input. Anybody have some advice about this one? Like, I honestly just don't even know where to begin because I don't even really know binary too well. Definitely one of my weaknesses. So A and B gives you 12. Given 2 binary strings. Oh no, so this is 1, 1, and 1. So these are binary strings. And you sum them. So if I put those on top of each other, so no matter what, convert to base 10, then do the sum. You say? So what does 1 represent? Just 1. And then 1, 1 represents 3. So 1, 0, 0 represents 4. So then this is what you have to do then. Can we use the bitwise OR, the XOR operator basically? Iterate over, line up values. I honestly don't even really know. Like, in terms of, I'm just not really that knowledgeable on binary stuff in Python. I do not have a lot of practice with it. So, in this case, example 2, if you line up a 0 and a 1, you produce a 1. But if you line up 2 1s, you produce a 0. If you line up 2 zeros, you produce a 1. So in the case where there is a 0, this is our chance to practice. Okay, it's a good mindset to have. This is our practice. Does anybody want to do some coaching? Or like, you know? Given 2 binary strings, A and B, return their sum as a binary string. So a binary string of length converting to base 10. Well, how would you even convert to base 10? So if you have, if this represents 1, 1 represents the digit 3. So the length is 2. First digit in base 2 is 2 to the power of 0. Second digit in base 2 is 2 to the power of 1. Third digit is 2 to the power of 2. Okay. To convert, one to the power of, so this is 1 to the power of 0, which is 1. This is 1 to the power of 1, which is 2. And so you add those together. So you basically iterate down convert binary on a string. All right, we'll make a helper function, convert binary rotation to a string. We say power equals to 0 for, and then we'll say length of binary equals n for in the range of n. When I want to say value equals 0. All right. Value plus equals to binary at index I to the power of value, and then value plus equals, to the power of power, and then power plus equals 1 on every iteration. And then so at the end of this, we're going to return value. So can we say converted A is equal to convert self dot convert on A, and then we'll do the same thing for B. Obviously you sum them. Total equals to converted A plus converted B. Return value 0. Okay, so that's fine. So even if you can't enter into the loop, it is still return value at the end, which is 0. Converted A, converted B, and now we need to do converted total equals to 1 times 2 to the power of 3, 0 times 2 to the power of 2, 1 times 2 to the power of 1, plus 0 times 2 to the power of 0, equals 8 plus 2. you have to do a base though times 2. Okay, so base. So you do. So you do the binary value times the base of 2 to the power of power. So that would be multiplication there next to that. Yeah, right? Since input is a string, much easier to go through each digit string I. The base is, so if the target number is 5, for example, find the numbers in the bases that add up to 5. For the first ones, I think, sorry, Marty, I'm not. Bases equals to 1, 2, 4, 6, 8. So on the target number, if the target number is 5, for example, find the numbers in the bases that add up to 5. For the ones that add up to the 5 mark. For the ones that add up to the 5 mark, them 1 and the rest zeros. So I'm multiplying it by 2 times the power, right? That'll convert it. Let me take this string. I don't even know if I'm doing this right because I'm really bad at, I honestly don't know anything about binary stuff, like hardly at all. The bin function? I'm not sure. I've never even heard of that before. I am working on Leet code problem 67, and I am pretty unfamiliar with binary, numbers, and it kind of seems like gibberish to me. I am attempting to write a helper function for converting the string binary number into base 10. Can you help coach me through understanding binary numbers and or notation and get a better grasp about how to solve this problem? I would prefer you not to show me code, but you can give me short, unrelated one-liners to provide as examples. All right, quite the prompt. Got it. Let's break down this step by step. Binary is base 2, meaning each digit represents a power of 2. Just like decimal, base 10 uses powers of 10. Each bit is either a 0 or a 1. The rightmost digit represents 2 to the power of 0. The next one represents 2 to the power of 1, then 2 to the power of 2, and so on. Example, 1011 in binary is 1 times 2 to the power of 3 plus 2 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 0. You should start from the rightmost digit and work left, updating the power accordingly. Can you spot the issue in your loop that might be causing incorrect results? Okay, so my loop isn't correct. So we start off with a power of 0. We take the length. We iterate over the entire length of the string. And we have a value is 0. We say that the binary at that, so that value in the binary string at that string times 2 to the power of power, which in the first instance is 0. We increased power Tim solved it. Dang, Tim. Showed me up. Bases 1, 2, 4, 6, 8. Find which numbers add up to target 5. Mark those as 1 and the rest as 0, for example. Since 1 plus 4 equals 5, the output of bases 1, 2, 4, 6, 8 would be 1, 0, 1, 0, 0. So you have to keep a number of bases proportional to the... What I don't get though is how do I compute the new digit? So in the example, in each case, right? In this case, you summed 2 together and you went to an output of 5 length. But in this case, you summed these together and you got an output of 3. So why was it in this case did we... It's just because we went beyond, we needed the extra digit to go to the next number. Whereas here, this was still had one more digit that could be represented by this. Well, because you can flip the 0 to 1, and then flip that guy to 1, and leave that guy 0, and then make them all 1s, and then that'll give you the largest number, right? So my loop is broke. I didn't know my loop was incorrect, LOL. Your logic is close. The issue comes from the way you're handling power. Right now, you're increasing it for after iteration, but you're starting from the leftmost digit. Oh, okay. Okay, so we need to go backwards. So then power should be the length. So we can just get rid of power, make this go length n, and then we don't want to reduce n though because that'll keep reducing it. So maybe we'll keep power. Make power also equal the length of binary. And then put power there and reduce power down by 1. So if I start from the front of the binary string, I need my power to be the length of the string minus 1. Right, so this needs to be minus 1. Then it will go down to 0 for the string index -1. Exactly. The leftmost digit has to have the highest power of the rightmost digit corresponds to 2, 0. So you should start at binary length of binary equals -1 and decrement as you move forward. So this is what I have now. Okay. This is what I have. You're really close. Binary is a character, not integer. So when you multiply it, Python will treat it as a string. Okay, so we have to go int binary at index I. Like such. Now you got it right. Converting binary I to integer ensures that you're actually doing numerical multiplication rather than string operations. Your function now converts a byte string to its base 10 equivalent. Woo! Nice. So then we need to convert to B10. Convert to B10. Right? And then we need to call convert to B base 2 on total. Right? And then we're going to return, once a string, convert string converted, return string converted total. Yeah, we got it, Wing Hong. It's length binary -1, right? So now we need to write a function def convert to base 2, which takes in a base 10 in the form of a string, right? So in order to convert backwards, we would have to do the reverse of what we did before. So go through every digit and divide it by 2 to the power of what it was. So then, now that I have a string that is the converted base 10 form of a binary string, I can I can call the function on the, so this is an integer string now that returns. So we're gonna have to convert these to integers again. See you, Tim. Thanks for stopping in. Am I making this problem way more difficult than I need to be, or I don't know. I feel like, I don't know. So then now that I have a string is converted to base 10 for binary string, I call the function on the A and B strings and convert them to ints and add them together. I then will have a total in base 10 as an integer and need to convert that to a string and to convert that back to base 2. Exactly. Now that you've converted the binary to decimal, you can convert A and B to base 10 using the convert function. Add the two decimals together. Convert the sum back to binary. For step 3, think about how binary works. You need to repeatedly divide the number by 2 and track the remainders. The remainders form the binary representation, but in reverse order, since the least significant bit comes first. Oh, interesting. So then we can go like this. For, we'll say n is equal to the length of base 10. For I in the range of n, we're going to go binary is equal to a blank string. We're gonna go binary plus equals to the base int base 10 of index I modulo 2, like that, and then return binary in reverse order. Is that how you do it? You repeatedly divide the number by 2 and track the remainders. So, do I divide the entire num by 2 over and over, or each digit? Each time you take the remainder, which will always be 0 or 1, and store it, the quotient becomes your new number. You keep going until you reach 0. Okay, so we say then, while so num is equal to base 10 converted to an integer. Then we say while num, we're going to do num remainder is equal to num modulo 2. And we're going to go binary plus equals to stir num. You're on the right track with this small. You're pending the number instead of remainder. Oh, whoops, sorry. Since the remainder. So then we need to go return binary -1. So each time you process a remainder, you need to update number. Okay, so we did the, okay, so that doesn't update the actual number. It just leaves number as is. So we need to go num equals num floored by 2. Like so, right? You're so close. Oh, the notation. Instead of slicing off the last character, you reverse the string at the end. Here's the idea. So start, stop, step. Okay, yeah, start, stop is 0, step is -1. So the start, stop, step. Okay. So then what we have now is we take in, we have a total here. So actually, I can just pass it in as an integer. I don't need to even convert num here. I'll say while base 10, base 10 and we return that. So then we take this, returns a string, we convert both of these to ints, sum them, total, convert to base 2 on total, and return string and converted total. No. The solution convert takes one positional argument, but 2 were given. Solution convert to base 10. Oh. Converted A. Just got some bugs here. Boom. Oh. Huh. Okay, so this is what I'll do. I'll take my 2 functions here. I'm going to copy them. I'll say, okay, I have a working solution, but I am getting caught on some edge cases, such as, right, often arise when A is 0. You might want to hit edge cases when A is 1 and B is 1. Ensure that if the binary sheets are 0 and 0, the output is 0 too. Consider how they convert to binary. Base 2 function handles when the sum results in 0. So in convert to base 2, consider how the convert to base 2 function handles when the sum results in 0. Return 0 sliced 0 plus 0, which is 0 is total. Convert on total. Base 10, while base 10, well, base 10 is 0. While base 10 greater than or equal to 0. Make sure so just greater than 0 because we want to stop. So if not binary. Okay, so if at the very beginning, if you just say if not binary. No, here. Return binary if binary, else quote 0. Right? This way, if the binary string is empty, the number is 0. It will return quote 0 instead of an empty string. Otherwise, it will return a reverse binary string. So then if I use this edge case and run with it, return binary, flipped. There we go. Okay. Not very fast. Oh, then. Hey, Obed. Thanks for coming in. All right, so that was number 67, add binary. So what I did was I created two helper functions, convert to base 10 and convert to base 2. I'm gonna be honest with you guys, I'm pretty noob at binary and understanding what it does. This definitely helped understanding that each digit just represents a number of 2 to the power of some integer or ith, and starting from 0. So to convert to base 10, you would just take that value and then multiply it by 2 to the power of its positional in the array, in its index, and then sum all those values. So that's what I did, was to convert it to base 10 is power is length of binary minus 1, because if we're starting from the front, or it could be length of binary, or it could be 0 if you're starting from the back. We say we iterate over all of the binary string. We convert each character to an integer and multiply by 2 times power, starting at length of binary minus 1. And we reduce the power all the way down to 0 for the last character in the array, or in the binary string. Then we call that on both A and B. We then sum them together. This returns a string. We convert them to integers and sum them. And then we convert that total back into base 2, which is a binary string, while we have a base 10 integer or value, right? We're going, while it's greater than 0, we're going to continually divide this by 2 and take the remainder, and that creates our binary string. Then we flip the binary string at the end, and then or else return 0 if it's blank. And then that's the gist of the function. Then you just call a string on that and return it. Right? So pretty cool. Not too crazy. I did need to learn more about binary stuff on this one. So I used the AI to kind of teach me about binary. It didn't write me any code though. I wrote all the code myself. Just use it to help me learn about what binary bases are and how to use them. Bad Butter, welcome, dude. Obed, how's it going? Welcome. Now, awesome to hear from you. Thanks for coming in. I suppose we're familiar with base 2 numbers. I think one might just add numbers instead of base 2 without conversion. Such as, as you said already a few minutes ago, 1 plus 1 equals 1, 0. Yeah, see, I'm not super familiar. Honestly, I don't really know. All right, cool. That was the Leet code problem for today. Let's go ahead and shift our focus. That was our 22nd Leet code problem we've solved so far. 22nd. 20 easies and 2 mediums so far. We're halfway done with that one. There's Mr. Tim's. All right. Cool. Let's go ahead and shift focus here. All right, you guys. So this is the Small Business Manager. I've been working on this project for the past, few months in terms of iterations. This is our second iteration of the project. We are currently developing a user interface, a graphical user interface, or GUI. We are doing that using Tkinter, and we're also no longer handling databases manually using file IO. We are now using SQLite 3 to handle our database interaction using query pulls and these tables. So what I have so far is this. This is what we got. So pretty cool so far. We've got a inventory tab where we have a matrix that houses ID, date purchase, description, size, cost, and status of each of these inventory items. We then have the ability to add items with this menu over here. And then we can search for specific item parameters and filter out this matrix with this search box here. So pretty cool. Pretty cool. We then have a similar approach for expenses, where we have add expense and search via its headers. And then we have transactions. So we made this one yesterday. This one, right, is a little bit more dense, where we have quite a bit more data present on our matrix, such as the item ID reference, the item amount that was sold for, the platform of the sale, the transportation and charge of those various that item, the fee and discounts, and a transaction total, and then a potential note for that transaction. And then you can obviously create transactions, commit transactions, and then search for various transactions, right? So I need to go to my transactions menu right off the jump here. And in the transaction search frame, I need to give this combo box a weight of 2. And that will make that combo box a little bit smaller. Or maybe it's the other way around. Let's give this the weight of 2. No, that makes it way bigger. Let's give that a weight of 3 and see what happens. There we go. That looks better. All right. So now what I want to do is I want to actually link up these matrices with, the items. So, how can I start displaying this? So we have, let's go to our inventory tab. Right? So this is our inventory tab. And we are in our matrix here. This is our matrix here. So I need to add inventory from this, right? So I'm gonna go like this. We're gonna create basically a query for all inventory is equal to db.execute quote, select, right, all from inventory. Simple as that, right? That houses an object, and then we're going to go all inventory is equal to all inventory dot fetch all. Actually, we don't even need to do this. We can just do dot fetch all here. Okay. So then if I call print on all inventory here and run this, what do I get? Nothing's happening. Let me take this over to here real quick. I'm going to comment out this here. I'm going to do this. Here. There we go. Okay, so we are seeing it. Let me comment out this. Okay, so we are getting it. So this gives you a list of just their information. The item number, date created, the test item, So will these be a list of dict objects or just a list of tuples with the values of each column in the tuple? The result will be a list of tuples, not dictionary. Each tuple containing the values of the columns in the order they appear. So for all items, I just select all from inventory, fetch all columns, get the column names. No. So then what I'll say is, this is all inventory here. So then we have all inventory. And now we need to go for row in all, for item in all inventory. We're going to go matrix tree dot how can I add SQLite 3 queries to a tree view into Kinter. Set up your tree view widget, fetch the data, insert the data. So fetch data, return data, for row and data insert. Values equals row. Tree view insert. Inserts each row in the database. TreeView.insert quote. What does this mean? The TreeView insert is used to insert a new row into the TreeView widget in the Tinker. Here's a breakdown. Insert. The first argument is the parent. The top level or not nested inside any other tree. Second argument specifies a position where the new row will insert relative to the other rows. The values will be the specific, specifies the data will be displayed in the rows. Tree.insert quote quote end and values equals to item. Okay, so now if we go run app.py, sweet, look at that. Look at that. What? Look at that. Hey, AJ Brady. Okay, so now we have those in there. Yo, no way. Okay. So then, that's awesome. So let's go ahead and now do that for the expenses as well. So the thing I'm curious, you guys, is how should I organize this though? If you guys have any comments, please let me know. Like right now I have this just going inside of my inventory tab, but should I make a database functions file basically that will be for these queries and then import the queries into here? Right. I don't know. What do you guys think? So now I'll take this. I'll go to expenses tab. Go to the expense matrix here. Paste that there. All expenses. Select all from expenses. Fetch all, print. We don't want to print all. For expense in all expenses. We're going to say expense matrix tree. Dot insert and expense. So now if we run app.py, we have no expenses there because we haven't generated any yet. Should be separate concerns. You can use dependency injection to be able to give access to different parts of your app. What does that mean? Losing a lot of jargon there, AJ Brady. Dependency to be able to give access to different parts of your app. Right? And so then this is for insert all expenses in matrix. So I probably because like right now I'm wrapping this entire class in SQLite 3. Like I have a DB close here at the end of the class because like I'm not really sure how to go about organizing this in terms of where to put the database queries and where to put like in terms of functions and stuff, because what I want to happen is that I want the user to be able to say, okay, I want to select ID 1 and then press search, and then this updates calls. When they press this, it will call a function for this query and populate the matrix as such. The front end shouldn't depend on specific implementation of the database, thus the front end should have access to some sort of database handler that the front end itself does not create. Okay. So right now, my front end, right, my Tkinter front end expense tab is loading in a connector of SQLite 3 and then using its cursor as DB. So then dependency injection is a fancy term for passing a dependency of an object to that object on its creation. So then, right, the expense tab, what it does is I call this, I get the headings. So what I should do is do a function for getting headings of a specific table, and then within the db.py, and then call that function at a single instance. Yeah, rather than create an engine in a car, you create a car and then pass in the engine, right? It's a good analogy. So then what do you think I should do for this, AJ? So like my setup is the exact same for each tab basically, where I have my frames and then I have my matrix, and I'm getting the headings by doing a database query within the actual class of the expense tab. Should I instead, at the top of my class expense tab, no, because I'm importing this, so I have to, this tab has to house the query result, but I don't want to wrap this entire thing in a DB close here. I want it to just be called and closed at that point. So then if you make the update, it calls and closes again and basically re-renders the page. Like it will call the function to retrieve the new headings or the new database information, and then it will call a function to populate the matrix, and then it will close the database from there, and then it's at that point frozen by just a rendering of what currently is in there, and then it's not live, right? I'm gonna go to the restroom really quick. Give me 5 minutes, you guys, to go to the bathroom. I'll be right back. Please stay with me here. Leave a thumbs up on the stream if you're here. I stream every single day, me learning and teaching myself Python. I'm building, quite the little application we got going on right now. So thank you guys truly for being here and hanging out. We're just working through some, understanding of our current structure and making sure it all works. So I'll be right back, you guys. Hello everybody, we're back. All right. Okay, so what do we need to do? What do we need to do? Okay. Let's talk through our thoughts with that duck here. I am building my small business manager UI and DB format. I am trying to better understand DB interaction with UI events and etc. Oh. Thank you. Right. I am going to show you my current UI. Now, this is just a single tab from the overall UI notebook using Tkinter. I am just importing the tab into my main app. I am wanting insight on how I can handle DB query and properly inserting the data into the tree view, etc. A nice project with a small business manager handling database interactions with a Tkinter UI based UI with a tree view widget that can be tricky, but with a proper structure it can be manageable. Here's a general strategy for integrating. Create a single connection to your SQL database if you're using that, and ensure it's accessible to all parts of your app that you need to query. You can do this in a separate class or module dedicated to the database interactions. Query select execution. Use a function to execute queries. Select, insert, delete, update, delete. You call these functions when you interact with the UI. Use commit for changes that affect and fetch results for read-only queries like select. After fetching data, you'll need to insert it into the tree view using treeview.insert for each row. When the user performs actions that modify the database, you also need to update the tree view to reflect those changes. Okay. Don't show me code. Knock it off. Okay. I am going to show you my. So let's start with the inventory tab, right? My inventory tab. I don't currently have a database manager class or anything. I just made the raw query inside the tab itself. What would you recommend for scalable and solid structure? So what I'm going to do is I'm going to take this inventory tab, I'm going to paste it here. Let's see what you guys have to say about it. To scale your application and make it more maintainable, I recommend structuring your code into separate components. Right now, everything is mixed into your inventory tab class, making it harder to manage your app as your app grows. Here's an outline of how you could reflect this into a cleaner, more modular design. database manager class. Instead of opening and closing the database connection within the tab, create a database manager class that handles all database interactions. This will help centralize your database logic and keep it separate from your UI code. Inventory logic. Your inventory tab should focus on only the UI logic with the database interactions. Queries, inserts, updates should be handled by the database manager. Event handlers. You separate the logic for handling the database, adding item searching from the UI. For example, when the user clicks the Add Item button, you would call a method on the database manager to add the item and then refresh the tree to show the new data. So here's a refactored structured outline. Database manager class. Methods: connect, establish a connection to the database. Fetch inventory, return all the inventory items. Adds items, adds a new item to the inventory. Search inventory, searches your inventory based on the criteria. Okay, so let's work on this then. So let's go to our classes. Right. We'll go into our classes. We'll open up a new file called database manager. Or DB manager. Class.py. So we're going to go import SQLite 3. We're going to make a class called DB manager or database manager, right? Database manager. And then we're going to define its initialization. Right, and so what do we do with the DB manager? Right, what we do is we connect. We connect to the DB. So con is equal to self dot SQLite3.connect onto this. Right. That's self.con. And then we say self.db is equal to con is equal to self.con.cursor, right? Let's catch up on your chats, Brady. Sorry. Database connection tip from GPT. There's quietly suggesting using dependency injection. Rather than having a global database connection, you create a single connection at the beginning of the program and pass it to the creation of the UI or the view model the UI is using. Rather than having a global database, you can create a single connection. You can have an inventory tab view that holds a database. Yeah, exactly. Okay. So we'll create this database class instance, and then in our app, we'll run it, and then we'll pass in the database into the notebook or something like that, or something. You'll have to see how it works. Okay. So we have database manager. So then we have a method here, def so once a connect method doesn't want to connect automatically on creation, on call. So def connect on self. It'll be this here. So then on initialization, you don't do anything. So then we have inventory related functions. So def fetch inventory. This is going to take in self. This has to connect though, right? So how do you pass in, like I'm calling fetch inventory here. Maybe have beneficial to have the connect function return some error if the DB connection fails. That's great. That's a good idea. Thank you so much. That's a great idea. Try except what would be the exception? So except, let's pull up a second instance of the GPU and say what error is raised on a failed DB connection for SQLite 3.db error. Try to connect, except for as error. Right, except for SQLite 3.db database error as E. And then they wanted us to say E was as E, then we'll say database connection failed. The inventory function should just return data from the query. So we'll say fetch inventory, but should I make a flag here for all? Can you add attributes on the fly to a class on the fly in Python? Yeah, I can assign self.con and db equal to, if I just pass in self. So let's see here. Let's see what it says. Here is my go at getting the DB manager class. You're off to a solid start with your DB manager class if you improve its screen manager scalability. Connection management, single trunk pattern. To ensure that you're not opening multiple connections and to avoid connection leaks, it's good to handle the connection lifecycle properly. You can use the connect method to get a connection, but also implement a close method to make sure that the connection is properly closed when not needed. So def close self. My C brain just died a bit. I knew that's something you could do in JavaScript. I didn't know you could do that in Python. Yeah, I mean, I think it's okay here. Why is... I've asked it not to show me code like so many times, but it just continually to show me code. Stop showing me freaking code, dude. It's really frustrating. I don't want to see your code, your trash code. Get your trash code out of here. Okay. Okay, so then fetch all, fetch inventory. I'll put on here a flag, which is by default equal to none. Or we'll say amount, rather. Amount is better, right? For an amount of inventory. So, amounts equal to, quote, all. We'll say half or we'll just implement all for right now. Okay, but that'll be our flag right now. So we'll say if, so you have to provide amount, right? So if amount not in amounts, raise value error. And then we'll say given amount param not in required params amounts, right? So then if we get past this, we need to say, you can have it be a number like a count of inventory items to query for. Okay, so if amounts equals all, if not amounts or not is instance amount, and then int amount parameters or integer, right? Or not is instance. Right? How about that, AJ? For a specific count. So if a number not in amount or not is instance of an amount type integer, right, raise value error. So if amount in amounts, then we'll do that. Meaning, because we already got past this, which means we know it's in there or a number, so we just need to basically go down that fork. So else, right? We're going to say amount equals to int amount. if it's in the amounts, we're going to say try, right? We want to try to fetch in case if it's not connected, then we won't be able to get it, right? So try db self.db quote select all from inventory. So then we'll say match case here, match amount, and then if it's the case of quote all, then we're going to try and do this, except for a SQLite 3.database error as E. Then we say print database not connected, call db dot call dot connect on database, right? Something like that. I don't know if it would be best to have an all option. Depends on if you would rather have a function specific that for you. I don't know if it would be best to have an all version. Depends on if you would rather have a function specify that for you. Yeah, so I think we're just like, isn't this okay? So far we're just splitting it up. What do you think? My hair's all funky. Hair's crazy tonight. So right, so we have an amount, so we can specify different amounts in here and encode them in. So if it's in amounts, then we can match it to a specific case, right? Else we'll convert it to an integer and say, right? Right, we want to do the same thing here, basically. Yeah, we're using this. So we're starting to reuse stuff, but I don't know if it's the best practice. So select this from inventory, and we'll put in a value of select right, this will be amount like such. So let's see what it likes. How does this look so far? Off to a good start. The basic connection looks good. You're catching database exception, which is great for handling potential errors. Currently, your initial method doesn't take any variables like self.con or db, which you might want to consider initializing them. Okay, so we'll say self.con equals to none, self.db equals to none. So then what we can do is we don't even have to do this, because if you have self.db is none, then you raise that error. Right, so if self dot db or self dot con is none, raise SQLite 3 dot database error as E. No, you're raising it. With a thing here saying this here. Right, and so then we don't even need to do this because we'll initially catch it at the beginning and we can just call all here, and then we don't even need to do it here either because we caught it at the beginning. Because we can detect if they're none. So right, if this, right? So this is raised. If database or self.con is none, raise this error as well. Right? If amounts in amounts. Oh, we got cookie round 2, guys. Cookies round 2 here. Here we go. Look at those guys.
I flattened them a little.
All right. They definitely look more cooked thoroughly here today.
ASMR.
All right. They're good.
Really?
Yeah. They're really good. Thank you so much. Woo! Look at that, guys. Quite the come up. All right. Hey, Prax. How's it going, man? What do you think about this, AJ? Right, so we have, now we'll make sure that they're not none, right? And so then we raise this if they're none. If amounts and amounts, we'll match it. Else, select all given the amount. And then what we're gonna do, this is going to do dot fetch all, right? And this is going to return I saw you were looking for new things to learn. Honestly, I'm really down for anything in terms of like just improving my general computer science knowledge on a deeper level. Whatever keeps the train moving. Okay. So try to close. So we'll say, here we'll say, what error is given on a close of a SQLite database that is not connected? It raises SQLite to a programming error, which is because you're trying to perform an operation and closing object has to valid state. Okay, so we'll say, except for a SQLite 3 programming error, as E print quote error E with an F string. Okay. So right now your connection method opens the connection but doesn't allow for reusability. The connection is already open. It might be useful to check if the connection is already established, and if so, skip opening a new one. So what error or indicator is given when a connection is already open? Will return the existing connection. However, if you're concerned about managing connection properly, ensuring you're not on track the connection state. Oh, so if it's none. Okay, so if self.con is none, then we're going to go ahead and do this. Oh no, not here. Here. If self.con is none, then we'll go ahead and try to connect. Else raise SQLite 3 database error. We'll print out error connection already error database already connected, right? So I'm going to take this and see what it says about that. This looks like a solid approach to managing your database connection. You've got a good foundation with the following: feedback and improvements. The connect method. You've correctly raised an exception database error when a connection is already open. This ensures that you don't open multiple connections unintentionally. Sweet. Close method. The close method is intended to close the cursor self.db, but is also needed to close the connection. But you also need to close the connection self.con. This should be done in a finally block to ensure both are closed properly. You can also check if the cursor or connection exists before attempting to close them. Okay, so we'll say if self.con for self.db is none, that is not none, then we'll try to do this in self.try finally self.close self.con.close. And then say else raise SQLite 3 database error programmer error, right? Probably programming error quote error database cannot close unopened database, not connected Unrelated. Closure failed. So let's see what it says about that. Your code is looking better. A couple of minor adjustments. Close method. You have a small issue in the conditional if self.con or db is not none. Will always evaluate to true because self.db is not none. Is the comparison expression will turn true if self.con is none. And so instead of or, it's and. Finally, we should close both the DB cursor and the connection block inside the finally. Self.db.close as well. Hey Joshua, thanks for coming in, dude. Thanks for coming in. I love learning about basic computer architecture and compiler language design. If compilers has language design, I have 2 book recommendations to choose from in it. If computer architecture, I have a few books. Don't be afraid to use Copilot on VS Code. Get used to using, but only if you understand what you're doing. You already understand that, and a lot of engineers don't. What do you mean by that, Josh? Yeah, that's kind of what I'm using the GPT here for. Is I explicitly say, don't show me code. You'll see me say that over and over and over again because it's kind of stupid and can't remember because I don't pay for an account. But I just use it to basically talk through my thoughts, like a duck would be, right? And just use it as like a peer and talk with it. And so and that's what really helps me to be able to convey my ideas and keep them kind of as it's kind of like a notebook, honestly, like a smart notebook. That's how I like to use it. And I like getting advice and like feedback. You might want to catch any exception when closing the connection or programming error. So except don't show code. Inside finally, make sure to attempt closing both the cursor and connection handling. Can you show me an unrelated example of using finally and try except? I've never done it before. Try to open the file, read and print, except for this. Print this. Finally, try to close the file, except pass. So try to So why would I need it here? In your database, the finally block is used to ensure that both the cursor and connection are closed regardless of whether an error occurs and try to block. Ensuring the resource cleanup. Database connections and cursor are limited resources. Failing close them can lead to memory leaks or performance degradation. So try to close self.db, self.con. right? Except for SQLite. Database error. So how about that? Okay, how about this? You're close, however, there's a small issue when checking if the connection or cursor are none. The expression if self.con and is not none may not behave as expected due to operator precedence. It will check if this is not none first, then it should evaluate to true as, and then to ensure both our values should change the conditional to if self.con and self.db. Oh, so if you have these, both of them, then try to close them. Else you can connect. Right. The main purpose is to ensure that certain cleanup. Okay, so what did it want? If self.con and db, try to close, except for this print, this is E. Except with programming error as E, print error as E, error closing database, right? Okay, so it just wanted me to specify better. And then it's saying, wants me to do it, catch the other error, the database error. Error with the database. And then we don't need to do this, else raise that error. Closure unsuccessful. Closure failed. AHA, do you have a job in programming field? I'm a student, currently waiting to hear back from an internship opportunity in the next couple of days. Awesome, dude. What region, where at, if you don't mind me asking? AJ is a junior. Cool. Senior in high school is practice. I want to do 2 years community before university to save money. Should I use AI during my years in school or just grind the books? Honestly, I would encourage you to try to, follow a similar format, honestly, of studying as me. Now, I'm not saying that this is the correct way of doing things, but I've found pretty great success in rapidly being able to learn pretty difficult things by prompting the AI in terms of conversation as you would with a peer or a teacher aide, and treating it as such. The teacher aide or peer would never be able to just directly give you an answer, nor would they want to do that for the academic integrity. So, really hold yourself accountable to that responsibility, and that'll also help you grow as an individual, in terms of taking responsibility, accountability for yourself in the field as a worker, and that shows great, that shows greatly, in the work field. Okay. Okay, so how does this look? Actually, just a final minor tweaks. Close, it's a good practice to close the cursor and then to close the connection. Okay. So you close the cursor and then you close the connection. More specific, while you're handling the programming sequence, it could be expected to catch exception as in all case. So then if you say accept exception as E and just say print error, unexpected error, unexpected. Like so. When I was studying for stuff in college, I really just kind of did this. I found great success in just going independently to the library on a nightly basis and just being alone, putting in my headphones and really focusing on checking things off my tasks, getting my homework done, and then setting some time aside to study, and then really rewarding myself after with video games or whatnot. But this is going to be the time to teach yourself these skills. And that's where people often sink or swim in college, is that they're not able to teach themselves these skills to be able to hold themselves to a higher standard of learning, and then it doesn't translate into the work field, and then that's why we have it's difficult, and that's why it's harder and harder to find good employees and things like that, because it's easy to say no. No, I don't need to do that, or I don't have to do. I'm late. Because no one's requiring you to, right? Nice, Wisconsin. Congrats, AJ. Hopefully, I'm rooting for you. Good vibes here. Okay. It'll tell me some suggestions and then keep suggesting stuff. Database not connected for proper grammar. It's really nitpicking me now. Okay, that's fine. Okay, so the fetch inventory, self and amount. Amounts can be all, if amounts not in amounts, or not is instance of int amount int, raise value error amount param not in required parameters amounts, or not integer or in required parameter, right? And then if self.db or self.con is none, then we raise this. This would be programmer error. Database not connected, call connect on the database. So we'll say just error, database not connected. If amounts in amounts match case all, select fetch all from the database. Else do this. Fetch 25. So I'll take this now and we'll see what it likes about this one. How does this look? Don't show code. You're already checking if amount is an integer, which is currently only all, and then you're checking for an integer type when the amount can only ever be all, or another specified string. This seems a bit inconsistent. The condition if self.b is none could be problematic. So we'll say, we'll go like this. Oh, jeez. Went down the wrong pipe. If self.db or con, then do this. Else, raise value error. See you, AJ. Thanks for coming in. No worries. I'll see you later tomorrow. Have a good night, man. Leave a like on the stream. Thanks for stopping by. Okay. So, if amount in amounts or not is instance of an integer, then we raise this value error. This function can either take strings as an amount for getting like all or half, etc. But it can also accept an integer for the amount and get that specific amount. To handle both string like all or half and integer in your fetch integer, you can make the following adjustments. You should ensure that amount is either a specific string or an integer. You can check the type of. That's what I'm doing. Did not see my function. You should ensure the amount is either a specific string, all, half, or an integer, and you can check the type of amount and its validity more clearly. So this should be and. Use self.db.execute. Oh, self.db.execute. If the amount is all or half, check those values and run the corresponding query. If the amount is select from inventory limit. Select all from inventory. Right, limit a question mark. Give it an amount. How does this look? I'm using the AI more than usual tonight because I'm trying to get some better understanding with SQLite 3 and understanding its errors and how I'm supposed to be properly querying things with a database manager and stuff like that. Condition for amount being a string or integer. You're checking if amount is not both not in amounts and also not integer. However, you should be handling two possible types. Your check should be modified to allow for this dual behavior. So if it's not in amount and it's not an instance of an integer, then we're going to raise this. You're using self.db select all from enter limit amount. It should be self.db.execute. The second argument to limit is needed to be passed. So we have to pass this as a tuple. The current way of using it is not going to do this code. Check if the amount is check if the amount is either in amounts like all or an integer. If it's a string like all, retrieve all rows. So if it's in amounts, okay, so if amount in amounts, then we'll go ahead and do this. So we'll say actually go like this. Bring this up. So if self.db and self.con, okay, if So if self.db and self.con, right, if amounts in amounts, right, else, if try, if amount, if is instance, amount, integer, else raise SQLite 3 raise value error error amount amounts. So like this, f amount error amount equal amount not in amounts or of type int. Okay, let's see how it likes that. Return your case. You need to return the result. Okay, so we need to return and then do dot fetch all there. If the query is intended to return rows, you should return the result of the execution rather than just executing without a return. Alright, I think that's good. Sweet. Nice. Okay. Now we have a fetch all. So what we can do is we're going to put on here, we're also going to do a def fetch headings. so this is going to be here. So we're going to put in self, fetch inventory headings, self, we're going to try, so if self dot con and self dot db, then we're going to try to do this query here. So we're going to try to get headings except for this stuff here. So we'll say this, right? This goes there. Try to get headings, else, except for exception. Say error unexpected. I'll put an E right there. So that. So fetch inventory headings. Let's see if it likes this guy. Yeah, come on. I'm returning the headings. Return that. The exception block could benefit from raising the error instead of just printing it. Exception. Raise exception. It's a good idea to return the headings if the query succeeds. Raise the error after catching exceptions to probably raise exception. Raise E. Like that. Is that how you do it? Raise exception. Unaccepted error. Accept exception as E. Great. Raise exception. Okay. So it likes that now. Cool. That looks really good. So now we have a fetch heading. So what we can do is we can go like this. So I can give a inventory tab. I can give it a initialization of a matrix heading. Headings is going to be a subtype list. Right? And then what I'll do is headings is equal to, I'll get rid of this altogether, then go columns is equal to self dot matrix headings, right? A part of this passed in, I will say self dot matrix headings is equal to matrix headings, and then we'll insert back into here on the headings self dot matrix headings, right? And then what I'll do is I'll go into my app.py, and right before I call inventory tab, I'm going to go like this. Matrix headings, inventory matrix headings. Is equal to matrix headings is inventory matrix headings, and we'll set this equal to the we'll go from DB manager class from classes dot DB manager class import database manager. Right, when I call this, we run app.py. We're going to call, we're going to take this, paste it here, make this go database connection. Right. And then we'll set under here the database is equal to the database manager class, and then we're going to go database manager dot connect, right? And then we'll go connect this to the database, and then we have db.close. So we connect. We go database dot fetch inventory headings. No worries, Prax. Thanks for coming in, dude. No, you're all good. I really appreciate you just being able to stop by, you know, for any sort of time. Just, you know, being able to hold yourself accountable is huge for, you know, learning or just, you know, hanging in and just stopping in for a couple of minutes is better than nothing, right? So thanks you so much for coming in, and time is really valuable. So I appreciate you spending your valuable time hanging out with me. So I'll see you tomorrow, man. Thanks for coming in. Hearts in chat for Prax. So we connect to the DB. We now call fetch inventory headings. We pass that in. And then in the inventory tab, I'm going to delete that for now. This is matrix headings. Self.matrix headings. Right. So now what happens if I run app.py? Ooh. No module name classes. Huh. Tabs. This is in here. Classes.database manager. If name is equal to quote main database manager. Oh. Every tab's done. Then app.py. There's GUI. Oh, GUI, app is in GUI. Tabs. So we have to do dot. So I merge my classes into the GUI. That will work now. So I run. Hey Wolf, bro, you inspired me to pursue a Python cert. That's awesome, dude. What course did you end up going with, Wolf? That's awesome. And how's that going for you? Let me know, dude. That sounds so awesome. Okay. So that works. We did it, guys. We got it to work. Look at that. Okay, so look what happens. So now, look what's happening, you guys. So now what we're doing is we have a DB manager class, right? I'm gonna rename this to app. So in our app, we have classes, tabs, the app itself, and so what we're doing now is we have a DB manager class itself, right? And what the DB manager class is doing is in my app.py, when I run main, I'm making a database connection. I'm calling database manager class, right? I'm making a database manager. I'm connecting the database manager, and then what I'm doing is I'm calling the database, which is the connection, right? Database dot fetch inventory headings, right? That function we just wrote, what we copied over that we were doing internally within the tab itself, we are now calling with a function, and then we are inserting that into the inventory tab as its matrix headings. So I'll say, right, inventory matrix headings equals to inventory matrix headings. And this is matrix headings. Right, and then so we're passing that in now from the very start of the creation, and then that is just being referenced, right, self.matrix headings for the matrix tree. And then if we run app.py for the inventory menu still has the headings up there. So it's working. Woohoo! Okay, right? So now what I can do, what's going to be interesting is I can go to my database manager, or I can go to the inventory tab itself, and I can remove this altogether here. And it should still work. So if I go app.py, run, inventory tab, we have to remove this db close down here. App.py, run. And we still get the headings, woohoo! Hurrah, hurrah! Right, super cool, super cool. So now, really quickly, if I go to my DB manager, let me go ahead and quickly Control L. Let's go git add, git commit, created the database manager class, linked DB manager base to app push. Cool. I'm just currently under a lot of doubts and mental sabotage as I feel I'm getting old and feel behind. Yeah, dude, honestly, it might seem foolish, but I feel that pressure as well at the low age of 26 even. So it's honestly just societal pressures and comparisons you're internalizing on your own, and you really got to break free of that and just really remind yourself over and over again for months and months and months that, you know, I can't compare myself. I can only do my best of what I've been given and what I have, and I can move forward from there. And I can only improve what I can control, and things that you can control, you can go really hard in, right? So I'm, you know, I can't control whether or not I get a job in this field or whatnot, but I can control how much knowledge and information I do obtain and how hard I'm willing to work to obtain that. So that's why I stream every single day, because those are the aspects I can control. So those are what I'm going to have control over, and those are what I'm willing to stress over. Anything else is out of my hair, right? No comparisons, no nothing. You're 26 as well. Awesome. It's great to meet a fellow 1999 birthday. 90s babies. Okay. So now I'm gonna have here is gonna be this is gonna be expense functions. Fetch. So we're gonna basically copy this entire function here, paste it here, bring this back. One. Def fetch expenses an amount. Amounts equals to this. There we go. Amounts is all. If self case returned from expenses. Right, fetch all is instance, select from expenses. Limit that, fetch all. Amount type of int, database not connected. Cool, that should work now. So then we can also copy over the fetch inventory headings. So this would be expenses headings. Right, self headings for execute from expenses. Description unexpected. Perfect. So now what we'll do is we'll go into our expenses. I'll show you guys this happening live. This is our expenses tab. I'm going to go into here and I'm going to remove these headings. So right, we're getting don't need that. Headings here. So we're going to delete that. Columns. Expenses matrix headings. Copy that. Copy that. See right now, and then I go here, pass in expense matrix headings of type list. We go self dot expenses matrix headings, and then we say that's equal to the expenses matrix headings provided. So now if we go ahead and go back to our app.py expense tab, we're going to pass in expense matrix headings is equal to, I'm just going to say an empty list. So what's going to happen is if I run app.py right now, there will be no headings on my expenses. Okay. Getting an error here on line 87. Oh. What happened here? Oh. Got copied twice. So now if I run app.py, oh, expenses tab, matrix, expense matrix headings, app.py, run, there should be nothing on the expense. So if I go expenses, no headings. Okay, look, no headings on the expenses. See you guys? No headings are on the expenses because I removed them and we're importing an empty list into the constructor. Right, our whole goal of this session was to remove the database queries out from the GUI constructors themselves and then just load them, pass them into the constructor via attribute parameters, and then have a separate database class be our handler. You okay? Okay. I'm almost done. Okay. So right now what happens, what I'll do is I'll come here to my expense tab. I will go expenses matrix headings, right? I'm going to call equals to the database dot fetch expense headings, and then I'm going to pass those right into here. Right? And so now, oh wait, yeah. So now what'll happen, which is really cool, is those will come back. So if I run expenses, here we go. Yes! Woo! We have headings again. Nice. So we are appropriately, we have now a third-party business class manager that will be able to handle all of these operations for us via function calls that we can do within our app now, not within our GUI, for each of the individual tab constructions. Have you learned all of this just from reading books? Yes, pretty much. So on the channel here, we start off the stream by reading, some various books. We've read Python Crash Course live on the channel. Right now we're reading Fluent Python and DSA in Python. All these books are found in my Discord link below, completely for free for you guys, along with my notes, chapter by chapter on them. And then I've done some courses. I've done CS50P and then CS50X. We're currently making the final project for CS50X. This will be my final project. It's more than enough for the final project of CS50X. And anyways, it's going good so far. So we've been teaching ourselves how to code for about 8 months now, and I've been really enjoying the process. But I'm going to go ahead and call it here, you guys. We streamed for a little over 3 hours this evening. We completed, we read 30 minutes out of DSA and Python today. We did a Leet code problem number 62, and then we did, we implemented a lot of great features here on our small business manager of this whole database manager class, and we incorporated a lot of functions here, over almost 100 lines of functions to do some various fetching for us of these headings and the inventory itself, so we no longer have to do those directly within the tabs themselves that's happening outside in our main app. So anyways, I'll see you guys tomorrow, where I'll continue on with our studying and learning. Thanks so much for joining me tonight.